it makes more sense for like a square wave than a... If I go back to this, I can do the rise time and the fall time, which is related to the slew rate. It adds them down here, right? But if I wanted to measure from something else, like if I wanted to measure something out of channel 3, then I have to click channel 3. Actually, yeah. When you click on it, when you activate a channel, all these colors change, and that any of these that you add are going to be for channel 3. So if I click this, now they're yellow, so they're for channel 1. So if I want to measure the positive width, now let's measure the frequency. It should be exactly the same. Yes, it is. But now I have the frequency, and if I add more values, they just start to get pushed off to the other side. Oh, it already exists. So now there's a bunch of garbage that is being measured for channel 3. And now it's down here. I can, if I don't like my screen real estate being taken up by these little statistical doohickeys, I can go back to the measure menu, clicking measure and turn off statistics. There's a button that lets you measure all, that just, so I have it, you can also change what it's doing. So this is only measuring from channel 1. So yeah, measure all just takes every measurement that I can and just throws it on the screen, which is great. So now you can find, anything really. Its max is 20, it's 2 volts, its min is 0 volts, its peak-to-peak voltage is the difference between the two of those. Its top and base are some number that I don't understand, probably like the 90 and 10th percentile. The amp, yeah, but all that stuff. Area, you can integrate it. Yeah, 223 microvolt seconds. That doesn't matter at all. So, but there's a bunch of things that are in here that don't matter. Turning off measure all because it takes up space. There's a counter that you can turn on that gives you just a basic frequency from some channel. That's kind of nice. I'm turning it off. So that's the other way to do more complicated measurements than you want. Say you actually want to measure the duty cycle of a square of some wave that's not just 50-50 duty cycle like I had. You can it'll actually try to calculate that for you. Or if you change from horizontal to, if you want the peak-to-peak voltages, you click this button, which is kind of mysterious. It took me a while to figure out how to do this. You click this button that changes this from the horizontal menu to the vertical menu. So now it has, average, the average voltage, the RMS voltage, the peak-to-peak voltage, so actually, oh yeah, there's 3, yeah, the peak-to-peak voltage, the maximum, the minimum, all that stuff. Amplitude. So this is how you get between horizontal and vertical. So that's the measure function. That can be really useful because then you can set up to take a measurement, you can change shit, and it will it'll update it for you. If you zoom in too much, it can't actually calculate. It doesn't like calculating for things that are, eventually it gets mad at you because it doesn't have like a full period, so it can't calculate a frequency. So it just puts a series of stars. If all time it doesn't have enough data to actually plot that. Now it has enough data to plot everything. So yeah.
I'm wondering just if people have questions so far, because you've covered a lot of information.
On, yeah.
Anything? Questions so far? I'm also interested in the GPS thing you did, so I don't want to.
Super early, and you have some basic thing you want me to go back on. It's hard for me to gauge like what level of familiarity with electronics and electrical components people actually have. Anything?
Is there any reference aside from the built-in help you can recommend?
I guess there might be a manual somewhere. You can Google for it. Okay. I don't know how well it's written. The built-in help isn't necessarily written all that well. For instance, I've found that these buttons, they all say the same. They all say yellow color, which is not correct. It's explicitly wrong. They changed the number, but they didn't change the color in all this. Like, the entire point of channel 1 being yellow is that only channel 1 is yellow, but this one, they all say the channel 2 are marked by yellow color, which are also used to mark both the waveforms on the screen and the channel input connectors. It's like, thanks. That's only true for channel 1. It's also not very well written. But yes, there's probably a manual. Yeah, I would Google it if you need the more complicated things, or the USB, you can take pictures and things, storage, I think is, yeah, you can store things. Wire lets you change some stuff.
Is there anything you should not do or connect to it that might be?
So it tells you what the limits are down here. All inputs are 1 mega ohm impedance, 13 picofarad capacitance, 300 volt RMS, Cat 1. So do not exceed 300 volts on these inputs. That's why you have the attenuating probes for large inputs, for larger voltages. That is actually a real thing in certain fields. I've actually, you know.
It'd be very unlikely that anything.
Well, yeah, I've had to worry about that, but y'all probably won't. Like I've had to worry about that at work, but that's different. That's what you're not supposed to do. Everything else, yeah, it samples. Apparently it measures up to 70 megahertz, 1 gigasample per second. These aren't, so I think it oversamples a certain amount because that's not the corresponding value for 70, but it doesn't want to, it's not going to really be able to plot anything that's going at a higher frequency than 70 megahertz. So higher radio frequency are not going to be very good. You want a more expensive oscilloscope for that. And the price goes up probably exponentially. Those are basically the limits. These things are pretty rugged. Again, yeah, this is the panic button. Oh God, what did I do? I forgot. It clicks a bunch of stuff inside it, which you can hear, and then eventually, and it reactivates a bunch of components, and then it gives you a set of, you know, it lets you, there's a couple, yeah, there's some basic displays that you can choose from. Click, 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 click. Come on. Something else.
So really, it takes a while to reset.
Yeah, it does, because it's kind of partially physical. It's actually switching stuff, and also it's probably not the fastest processor in the world. Yeah, so now it's reset to this automatic display that is sort of meaningless. So now we can use this because it's actually good enough for what I'm doing. There's an undo button. That's nice. I didn't know that. To disable channels 3 and 1 and just focus on channel 2. We go back to the GPS. So we go back. Everything has been reset. So I got to change change it to triggering off of channel 2. Note that how quickly the behavior changed. Changed to falling edge, as opposed to rising edge. So now it triggers when these things happen, as opposed to. So it's every second, right? So it has enough of a delay afterwards that it's actually missing most of the burst. So it's kind of just waiting for half a second, for most of a second, and then triggering, and then sort of waiting for. So, we zoom out, and then you can get. There's a whole lot of it's binary data, so you get like, it's triggering on this, and it's very difficult to read because it's going by really quickly, and it's a very long data packet because it's sending.
So what we're looking at is a data packet.
It's a set of data packets. Yeah, it's serial and communications, and it's going at I think 9600 baud, so that should be 9600 sample bits per second. So the time step of this is 1 over 9600 seconds, or 1 over 9600. In seconds. So it's sending a pretty long paragraph, sending several sentences. Let's turn off auto scroll. It's sending basically every second it sends all of this. So that's a lot of, and it's sending it as ASCII. So it's, so this thing is decoding it really simply. So each one of these is like 8 bits. So it takes like half a second to do this because I'm only going 9600 baud. If I wanted to update my GPS faster, I'd have to increase the baud rate because otherwise it would just trip over itself. Because it wouldn't be finished sending the last data before it started having to send the next one. Or I could disable some of these sentences, but I have no idea. That's much harder to do. It doesn't, my GPS does not have a fix because its antenna is here and not over by the window. So there's a lot of zeros in here. Actually a lot of commas and garbage. But it's like a sort of, there's a lot of defaults that is not correct. Anyway, so it's sending garbage through the line, and it looks like this. This is the actual signal that it's doing, and the peak to peak is, it's not quite 3.3 volts, but I have this. Instead of using this thing, which is really hard to get to attach permanently to my, I don't have any headers sticking out in the lines that I wanted, so I put one of these BNC to grabby thingies adapters and just grab the lines. I can also accidentally unplug it, and then it restarted. And here's what it sends when it restarts. It's SkyTrack Venus 6 kernel version, so I can actually see that.
So is there anything in the oscilloscope that we can derive from
So if I didn't
Can
know
you
what
get the
this
first
was-
letter? Yeah.
So if I didn't know what this was, I could, what I could do is, let me go back to, so you can actually, if I zoom out more, I can actually, you can see like, see now, way up to 100 milliseconds per division. The whole packet, it really takes like half a second. So that's the whole transmission, right? And I can zoom out to this level, which is pretty dramatic. And then, what I like to do for this...
So one thing you're doing here is
Yeah.
you're diagnosing that there is a signal.
That there is a signal, and I'm finding out, on both a small scale, what is it doing? Oh, it's binary, because it's a lot of zeros and ones. It's a lot of high to low, and with very short jumps. So it's not an analog signal. It's not sending analog data. And it's sending it at some rate, which I can sort of look at by looking at the size of those things. And then I can also get what's the length of the transmission. Oh, it's going to be, it's about 450, it's about 450 milliseconds, because it's 4.5 of these blocks, right? And I can just sort of glance at this to look at it. So that's nice. But now I know, by the way, that if I want to go at half a hertz for this GPS, I need to turn the baud rate up, which I wasn't sure about before, but now I know. Like just because this is, and in fact, I'm not sure. It might actually be longer if some of these are not zeros. Like, I think if there's some of these are. No, actually, never mind. This actually transmits a full set of data. It just transmits garbage. 4118.242 is... Oh, maybe, no, it's not valid. Anyway, but sometimes, the data packet length might change depending on what's being transmitted. For certain controllers, certain devices have all kinds of wacky requirements that you have to manage like that. But, so what I can do is... First, I'm going to change the mode to normal, which is a mode in which it doesn't display. It doesn't do the auto scroll when it doesn't have a trigger. It just refuses to display anything. It says wait. It does not update, right? And it waits for a trigger forever until I move the trigger level down in this case, and then it triggers. Yay! Okay, great. So now it's doing wait triggered. And now what I'm actually going to do is I can either click it here or I'm going to click it here. I'm going to hit single. So I'm going to do it. It does one and it stops. So that's great. And now it's done. This is bright red, and so now it's not taking any data. If I click this again, it'll start taking data. But now I can just analyze this. I can take a picture. I can export this data to a disk, I think. But what I'm going to do, I'm going to zoom in because it takes a lot of samples per second. So even though it's plotting at this range where you can't see anything, I can actually zoom in all the way until I can read pretty reasonably. Like that's, I can actually look at the individual bits. In fact, it has plenty of resolution. It has a huge amount of resolution. It has way more than I need to read a binary data set, right? So now from here, I can be like, okay, well, this is obviously the clock rate. This is the bit rate, because that's the smallest one of these blocks that I'm seeing. And this thing, when it's normally, it holds it high, so it's normal high, so the lows are ones. That's usually how this works, is that this is that if it stays this way while it's not transmitting, then that's 0, and this is 1. So this is going to be like 1, this is like 3 ones, a 0, 2 ones, a 0, 2 ones, 2 zeros, 1, several zeros. This is probably the beginning of a packet, so this is probably some overhead. There's some other stuff that it has to do, because it has to tell the other thing to listen. So eventually, some set of 8 of these is going to be a byte, and it's going to be encoded little endian or big endian, so in some direction, I don't remember which, but it's in the data sheet. And then I could, assuming I know, which my start and stop is, which I don't, but if I grab any of these, it should actually be, I should be able to translate that into a byte. And then if I have any idea, in this case, I know it's sending ASCII characters, so I know it's sending letters. And so I can translate that into a word. And so I could transcribe it painstakingly, piece by piece, if I wanted to. Because it's just sending it in clear. There's no like encryption or anything. This is just data, simple data. So that's a neat thing, and I like the fact that I can zoom all the way in to read the individual bits that it's sending, and then zoom all the way out to see how long it takes to send the whole packet. I think that's fantastic. And I know that I was not present for this, so I don't know the details, but I know that there is a sign. This thing it's like one of those, I guess it's one of those warning signs, like...
Yeah, like it's a LED road sign. And
yeah, a bunch of people figured out how it worked by plugging it into the oscilloscope and painstakingly decoding it.
We reverse engineered it by and each pixel on the sign represented a 1 or a 0, but there was a header that we didn't know what it was.
Right.
And we used the oscilloscope to be able to collect the data to see at the beginning of each set of data because it would refresh periodically and understand. Basically there was like a welcome sequence, and then we figured out where the data was, and then we were able to replicate the welcome sequence with a computer using a serial connection, and then display arbitrary sets of ones and zeros.
Did you need to decode the header and reproduce it, or did you need to? Right, so you needed to copy. You needed that. The certain part of the signal was overhead. It was a header, and you needed to prepend that onto your message, right?
Yeah, basically it said like, "Hello, I'm legitimately
I'm an authorized computer.
I'm the sign controller.
Yeah.
Display my dots.
Yeah,
and then I'm starting now.
My message has this many characters in it, has this many bits in it, and then I'm starting now, and then probably at the end there's a checksum or something that there usually is. It says, and if this is wrong, then
don't do what I just said.
Something failed. Yeah. Yep. But then, if you're going to reverse engineer it and program in arbitrary waveforms to send, via serial, if you're going to like go into your Arduino and tell it to send a certain, digital waveform, into a zero controller, then you're going to need to find out what the header is, just so you can, if it's just something that you can copy and paste, you need to be able to copy and paste. But it's a digital signal, so you can't. There's no, this is how you copy and paste it. This is how you copy it. But But you got to figure out if you copy too much, then it's not going to work, right? Because you copy too much, then it's going to always be the same first character.
Yep.
Yeah.
Yep.
That's really cool. Yeah. Does it still work?
Yeah, you can hook it to a computer.
All right, cool. You just show me that after this.
All right, yeah, I'd have to.
I would love to, yeah. Or maybe we should set up an Arduino and a keyboard or something.
Yep.
Anyway.
Cool.
So those are for the two use cases that I can think of that aren't, high voltage devices or radio frequency devices. Yeah, I mean, if you have a, there's also like the math menu. You can do FFTs of things. You can do crazy shit. This will Fourier transform your data. It doesn't like me, so that doesn't actually work this time. But yeah, there's a billion other things that it does that I'm just not showing because I'm not worrying about it. It did not, because I had channels 1 and 2 disabled, it didn't actually save that data. So I'm not running, right? So I try to enable channel 1 to see what it was doing at the time, and I don't know because it wasn't saving that data. So that's, that's just sort of how that's its internal logic. And if I go back to run stop, have it triggering, I can force. Actually, I can do single. Do that. And force trigger. I don't know if that works. So I'm gonna do. Fine. So it's not triggering now, and so it's just going to be scrolling. It's fine, but I can force it at some point. It doesn't look much different, but whatever. Anyway, so there's a variety of things that you can do. Any questions? Anything else?